In this example, we're going to put together work, and we're going to put together energy, and we're going to put together conservation of energy, and such like. So let's try a thing. A car, let's do a car, is driving up a hill. Driving up a hill. So it starts off, if it starts at the bottom at 12 meters per second, at 12 meters per second, and we'll say mass equals 1200 kg. I like 1200 kg. At 12 meters per second, and it accelerates to 15 meters per second while going up 20 meters over 800 along, and let's make that, and 800 along. If the friction is, well, it's good friction, 200 newtons, let's just say, what is the power required? And there's so many things going on here. A huge number of things. Okay, so first of all, let's draw a car. Draw a picture. It drives up a hill. Okay, so it goes up 20 meters. It goes along 100 meters, 800 meters. So, how are we going to do this? We need to find out power. Power equals, well, change in energy over change in time. So if we can work out the change in energy, then we can work out, and we can work out the time, we can work out the power. So do we know the change in energy? No. But can we work it out? Yes. Do we know the time? No. Can we work it out? Yes. With all the stuff we've done today, hopefully. So we write down what we know. Mass equals 1200 kgs. VI equals 12 meters per second. VF equals 15 meters per second. What else is there? We've got H equals 20 meters. D equals 800 meters. Gravity's going to be 10. I'm going to use 10. Gravity equals 10 meters per second squared. I'm just using that because it's easier. So let's work out a couple of things. Energy initial equals, well, EP plus EK. Is there any potential energy? No. Plus half mv squared, which is equal to half 1200 kgs, 12 meters per second squared. So that's equal to half 1200 times equals 86,400 joules. So at the bottom, VI equals 86,400 joules. Then, what else is there? Well, E final equals EP plus EK equals, well, in this case, it's gone up a hill, so plus half mv squared equals 1200 kgs times 10 squared times 20 meters plus half 1200 kgs times 15 meters per second. Okay, so 1200 times 10 times 20 equals plus 1200 times 0.5 times 15 squared equals 375,000 joules. So there's 375,000 joules of energy at the top. The final equals 375,000 joules. So change in energy equals E final minus E initial equals 375,000 minus 86,400 joules equals 288,600 joules. So this is cool. So this is 288,600 joules. But not so fast, not quite so fast. You think about it. This is just the change of energy, but there was also work done due to friction, plus work. So the work is equal to force times distance, which is equal to 200 newtons, times 800 meters, what's that, 160,000 joules. So what we actually have to do is the motor in this car, the car engine, has to supply this 288,000, which shifts the car up the hill and accelerates it, and it also has to overcome the friction. So the total amount over the top is going to equal that. Now the next question is, so this is a change in energy plus work. Do we know the time? No. Can we work it out? And the answer is, yes, we can multiple ways, but let's just use kinematic equations. So if we're using kinematic equations, using kinematics, what do we have? We have VI, we have VF, don't have A, but we do have VI, VF, D. So D equals VI plus VF over 2 times D. And if we rearrange that, that becomes 2D over VI plus VF equals T. So just flip that over as it take it across. So T is equal to twice the distance, 800 meters, divided by 12 plus 15 meters per second equals 1600 divided by 27 equals 59.26 seconds. T equals 59.26 seconds. Okay, so 59.26 seconds. So we go 288,600 change in energy plus the friction 160,000. Should put those in brackets, I suppose. 288,000 plus 166,000 divided by answer equals 7,570 joules of energy. So the power, watts, because it's joules per second, 1 joule per second. 7,000. So what's that about? That's 7.5 kilowatts of power. Yeah, does that seem reasonable? Well, my car will boot out maybe 140 kilowatts. So yeah, that seems reasonable. Not even pushing it hard.